On yesterday's tute, I came across a question from Washington, which I think is very, very useful and is worth doing in the class. We basically finished trigonometry section. So what I'll do, I will solve this question together with you right now. It incorporates many, many parts of trigonometry section. And after that, I will give you some useful formulas about sine and cosine, which can help you with the assignment. If you have problems deriving the relations like I did using unit circle, we'll do it as well. So the question I'm talking about is 27 from section 4.5 of Washington. What we have here is this. We have this three-dimensional picture showing a three-dimensional object like this. My picture must be perfect. Like this. We need to find the angle in the taper shown here. Here's the angle. Theta. What's given? This side is A. The height will be B. We had a discussion what this B means. To me, it means the height of this pyramid. To me, it is distance along the vertical in three-dimensional space. That's how I take it. What do you think? Would you agree with me? This is how it's depicted in the book. So I take it as a height in three-dimensional space. So it is not the length of this side. Would you agree with me? I believe that it's the height. not the length of the side. And this side is C. And this is C. We need to find theta, the angle. So what would you do here? You know what I'm going to do? I'm going to cross this object like this, like this. And consider this a cross section. Now let me move this A and C a little bit, so they don't come in the way. A and C. Why do I want to do this? To cross this object like this? Is because I know B. B is the vertical distance along the vertical. And I need a plane which contains this vertical. This plane which I just shaded contains this vertical line. Here it is. And now what I want to do, I want to consider just half of this cross section, which I'm highlighting right now. Okay, is it clear? So now let me look at this 3D object from one side, from lateral side. And what I see is this cross section. I'm not happy about the lower side. Like this. Wow, this is very good. Now, half of it I highlighted here. Where is it? Here. If I look from the right, the part which I highlighted in bold, in thick font, will be to the left. Here it is. That's what I see. Yep. This length at the bottom is C. Because apparently the two base, each base of my pyramid is a square. So this is C, this is C, this is also A, and this is A, and this is C. Look, please follow me, and if you have any questions, ask immediately. So if you don't ask, I understand that you totally understand. Yep. Now, this will be B. This. Do you guys agree? This is 90 degrees. Let me continue. This line down to the corner, where it will meet with this line. On my plot, a 2D plot, I will see this. Okay, that's what I will see. Now, I want to introduce some notations. This will be X, this length. This will be Y. Now, you know, I have a plan. My plan is this. Apparently, the angle theta lies in the plane, which is not vertical. This triangle with these corners, these three corners, this triangle, to which the angle theta belongs. I repeat, this corner, and this corner, they make a triangle. And theta belongs to this triangle. True? This triangle is not vertical. Okay. Now, I want, but what is given to me, in addition to A and C, is B, which is on the vertical. So I need somehow to connect to this vertical, to include this information. B. I need to include B into the game. Hopefully, as a result, I will be able to find X and Y, which belong to that triangle with the angle theta in it. Where are these X and Y? This is X, this is Y. Do you guys agree? Who doesn't understand how it looks in 3D space? You understand? So X and Y, they these two lengths, two lines, they belong to that triangle in which theta is. Now, I'm just trying to write some relations connecting all the symbols here. Now, as I start doing so, gradually the plan will become more clear. In the beginning, when I saw this problem for the first time, I didn't have a clear plan. But as I start writing some relations, the plan became more and more clear. And look, this is how it becomes more clear. Okay, look. Consider this picture here. Consider two triangles. One is a big triangle with these three corners. 1, 2, 3. The big triangle. And consider the small triangle with these three corners. 1, 2, and 3. Let me see, hold on. No, this is not what I want to do. This is not what I want to do. No, what I want to do is this. I want to draw this vertical line and simply express and consider this triangle with this, which I'm shading right now, this triangle. This small triangle, that's what I want to do. This is a right triangle, true? The distance from here to here is b. I'm asking, what is this distance from here to here? It's the difference a over 2 minus c over 2. So what I want to do now, I want to apply the Pythagoras theorem to this shaded triangle. What the Pythagoras theorem says? It says x squared, the square of the hypotenuse, is equal to the square of one side plus the square of the other side. The other side is here. It is a over 2 minus c over 2. All squared. Do you guys agree? Yep. Okay, so from here, from this equation, I know x. This will be equation 1. What I want to do now is this. I want to consider this triangle, which I'm shading right now. It is not in a vertical plane, but this is that triangle to which my angle theta belongs, or to be precise, half of theta. Now let me plot this triangle separately. Here's that triangle, which is not in the vertical plane. This line is bad. I have this vertical line. I had this horizontal line. This side is a over 2. This side is c over 2. You guys please check, because I don't see the previous slide. Is that correct? Now this was x and this was y. True? And this angle is obviously theta over 2. It's half of theta, right? Okay, so far what I achieved is the expression for x. It was x squared equals, what was it? B squared plus a over 2 minus c over 2 squared, right? True? Like this. Equation 1. What? I think I don't think that x should. X is the hypotenuse. Look, this equation 1 is not about this triangle on this picture. Yeah, look, this relation, equation 1, has nothing to do with this picture. Okay, you understand? It's about that triangle which I shaded. It's about the picture to the right on my previous slide. Right? And there, x was hypotenuse. Okay. Now, let's consider two triangles. One is the big triangle with these corners. 1, 2, 3. And the small triangle with these three corners. 1, 2, 3. I can even shade the small triangle, just for clarity. Okay, now what I want to do, I want to connect theta, c, a, x and y using these triangles. Let's consider the big triangle. I say that a over 2 equals x plus y times tangent theta over 2. Why is that? This will be my equation 2. See why this is so. Consider any triangle. Just forget our problem for a moment and consider any right triangle. With the sides, let's call them capital A, capital B, and capital C. And let's denote the angle by alpha. And let me write this. A cos alpha equals C. Do you guys agree? You should remember this. This is a formula to know. Yep. Okay. Can I write at the same time this relation B? Sorry. I shut the door. Now let me write this second equation. A times sine alpha equals B. Do you guys agree? Now let me divide equation, this will be equation star, this will be equation 2 stars. Let me divide 2 stars by 1 star. So I divide the left hand side of 2 star equation by the left hand side of 1 star equation. What do I get? I get tangent alpha, don't I? So I divide A sine alpha by A cos alpha. That's what I have on the left. What I have on the right? On the right, I have B over C. Is that so? Left-hand side divided by left-hand side, right-hand side divided by right-hand side. True? A cancel out. So what's left is tangent alpha equals B over C, because sine over cosine is tangent. So tangent alpha is B over C. By the way, we know that this is so even without all this mathematics. That this is what tangent alpha is. I could have written this relation straight away without equation star or two stars. Now from here, B equals C times tangent alpha. True? This is exactly what my equation 2 says. A over 2, which is similar to B, capital B, equals x plus y which is similar to capital C times tangent theta over 2. And theta over 2 is similar to alpha. True? Do you guys all follow me? Okay. Now, let me consider this small shaded triangle here. Let me apply this same relation to this triangle. I have C over 2 equals y times tangent theta over 2. This will be equation 3. Do you guys understand? So C over 2, one side equals y, the other side, times tangent of the angle adjacent to that second side. Now, what we achieved here, look, we have three equations and we have three unknowns. Are you okay that I never substituted any particular numbers? Look, in this book, in the Washington book, we have specific numbers. A is 4.5 centimeters, B is 4.9 centimeters, and C is 1 point, I can't believe it, 86 centimeters. So I ignored all these numbers and instead I used letters ABC, whatever they may be. Okay? So I'm going to solve this problem in general. ABC are known. ABC are given. Not known are x, y, and theta. Do you guys agree? X, y, and theta I don't know. A, B, and C I know. Now, how many equations do we have? Three equations. How many unknowns do we have? Three unknowns. What are they? Again, x, y, and theta. Yep, we don't know them, but we can find them because we have as many equations, as many unknowns. Now, from this moment, we just need to use some mathematical manipulations to solve this system of three equations. Solve for theta eventually. We are theta eventually. Let's see, how can we get our theta from here? Look, before in this course, we used to solve systems of linear equations. You remember? Systems like m plus n equals 0, m minus n equals 1, something like that. Linear. Systems. But here we have a difficult, at first sight we have a difficult problem because we have a non-linear system. X, we see x squared. We have theta under tangent. So at first sight, this seems to be a difficult system to solve. But actually it's not as difficult. Look, what I want to do first is to realize again that x I know. X comes from the first equation. X will be just the square root of what I have on the right hand side. Now, look at equation 2 and equation 3. Equation 2 has in its right hand side the product with this multiplier tangent, and equation 3 also has this tangent as a multiplier. So you know what I want to do? I immediately want to divide one equation by the other to eliminate tangent. So my purpose is to eliminate my unknowns as well as any way I can. Okay, theta will be gone for a moment, but of course eventually we will get it. This is our purpose, this is our target. But for a moment, as an intermediate step, we will eliminate it. This will help, you will see. So, what I'm going to do, I'm going to divide equation 2 by equation 3. Now I need your help restoring my equations. The first one was x squared equals b squared plus a over 2 minus c over 2 squared. Please check. Second was what was in the left hand side? A over 2 equals x plus y tan theta over 2, right? And lastly, c over 2 is y, true? Tan theta over 2. Okay. From the first equation, okay, I leave my first equation alone for now. Now I divide equation 2 by equation 3. I don't like division by double dot. I like slash. Okay, 2 over 3 gives me what? A over c on the left, on the right, x plus y over y. Agree? Where did these numbers 2 go? Where did it go? Why do I not have them anymore? Because they cancelled out. Because when I divide left hand side by the left hand side, I get a over 2 divided by c over 2. And these two are gone. Now, tangents are also gone. From this equation, my new equation, what I want to do, I want to move y to the left, get a over c, y equals x plus y. By the way, look, the plan now really materializes. Look, equation 1 gives me x. This new equation here gives me the connection between x and y. So if I know x, I will be able to find y from here. Then after I've done so, after I found y, I will substitute it in here into equation 3. And from this equation 3, I'll get my angle theta. Now the plan becomes really clear to me. Okay, now, how is y connected with x? I want to move this y to the left. And on the left I have a over c minus 1 times y. On the right I have x. Is that so, guys? Because on the left I have a over c, y minus y. And y is a common factor. And inside the brackets I have a over c minus 1. Okay? Now, what I want to do is this. I want to take this equation and take square of this equation. I want to raise both sides of this equation to power 2. I can do this because if a equals b, then a squared equals b squared. I can raise each side by 2 to any power. As long as the power is the same for both sides. Why do I want to do this? I want to do this because I want to create x squared on the right. And having done so, I will substitute x squared from equation 1. So, I take square of this equation for both sides. What do I get? I get this. Let me move up here. I get a over c minus 1 squared y squared equals x squared. Okay? I raise again this equation to power 2. Now I take x squared from equation 1 and substitute in here. I get this, a over c minus 1 squared y squared equals b squared plus a over 2 minus c over 2 squared. From here I get y. How to get y from here? Look, I'm asking you how to get y. I move a over c minus 1 squared to the right and get y squared equals b squared, the whole right hand side, plus a over 2 minus c over 2 squared divided by a over c minus 1 squared. True? Let me simplify a little bit the right hand side. Do I want to do this or not? Maybe not. So what is y? Y will be the square root of the whole right hand side. That's what y is. True? And of course, I do not write plus or minus. I only need the positive sign in front because I'm talking about distances. All distances in my question are positive. Now, after I take the square root, on top I have b squared plus, let me write it like this, 1 over 4 a minus c squared square root. And the denominator will be simply a over c minus 1. Like this. So I know y. Now I use equation 3. I really don't want to go to the next slide because I don't want to forget what I have here. What I'll do, I will erase something to free space here and continue on this space. Oh. And I will continue here. So y equals okay, y is already found. Y is already found. Now I find theta from equation 3. Tangent theta over 2 is c over 2 divided by y. And in here I substitute y that I found. So this is c over 2 divided by this whole fraction. True? The enumerator of my fraction appears here below the fraction line. And a over c minus 1 appears above the fraction line. What I want to do now, to simplify a little bit, I want to open these brackets on top to get a over 2 minus c over 2 over that square root, which is 1/2. Well, let me write it down like this. Let me write it down like this. A minus c. This 2 goes down in front of the square root, it appears. And then I insert it under the square root as 4. You will check it at home. 4 b squared plus a minus c squared. This will be it. So I have found tangent of theta over 2, which means that I basically found theta. So what you have to do now is to substitute a, b, and c in here. Use your calculator. Calculate this right-hand side. Get a number. This will be your tangent theta over 2. Then find what your theta over 2 is. Tangent of angle theta over 2 is that number. Find theta over 2 from using calculator. You will have theta over 2 equals what you have found. And then your theta will be 2 times what you have found. You can do this at home as a homework. Any questions, guys? Those equations that I promised, I will show them next time.